Okay, and finally, we're up to example 6. Let's talk about the graph. We're not actually going to graph in this section, but we can sure talk about the graph. So for the polynomial function f of x is equal to 2 times the quantity x minus 3 times the quantity x plus 4 to the third power. Okay, so we want to list each real zero and its multiplicity, then determine whether the graph of f crosses or touches the x-axis at each x-intercept. So we can do this. Part A, we know our zeros. And those zeros are coming from each of those factors. Notice it's in factor form. So the 2 out in front is just a leading coefficient because there's no x attached to it. It's not going to impact the conversation about zeros. This 2, again, if you set 2 equal to 0, gives me nothing. It doesn't tell me anything, so we don't need to do that. We set that x minus 3 to 0, we'll get an x equal to 3, and it has a multiplicity of 1. That's its outside exponent. The other 0 is coming from the x plus 4. If you set that equal to 0 and solve it, you'll get a negative 4. And its multiplicity is that outside exponent of 3. Those multiplicities are telling us what the graph is doing. If the multiplicity is odd, which both of these are, then the graph is going to cross at that x-intercept. So we're going to say the graph will cross at both, or you can say it again down to the graph. Now, just to make sure you're pulling all the information together, notice this, the 3 would be an x-intercept of 3, 0, and this negative 4 would be an x-intercept of negative 4, 0. So if you were writing them as intercepts, make sure you write them as intercepts. Part B says determine the end behavior. In other words, the power function. So if we were to multiply all this out, we would end up with a 2x to the 4th. So the 2 is obvious coming from here. We have an x, and this is an x to the 3rd. That would give me an x to the 4th. So the only reason to look at the 2 is whether or not it's positive or negative. So it's got a positive leading coefficient, and it is an even power function. So because it's an even power function, then our end behavior is going to be something like this. And I'm just going to draw a little picture. So I know it's going to start above, and it's going to end above. And that's because it was an even power function. And the leading coefficient is positive. A is greater than 0. So all that I'm pulling together and doing this. Again, this is a lot of analysis that I'm doing in my head that I don't really need to write down. Part C says to determine the maximum number of turning points. Well, the maximum number of turning points comes from our degree. And we know that this is a 4th degree polynomial. So n is equal to 4. We're going to take that 4, we're going to subtract 1 and end up with 3. So at most, this thing can change direction 3 times from the start to the finish in terms of increasing and decreasing. And we've analyzed the graph. And what we'll do in the next section is actually come and graph these functions. But for now, that's all they're asking us to do. Okay, let's do another example. So example 7. Basically the same directions for the polynomial function f of x is equal to x times x plus 2 squared. We want to come in and find the x and y intercepts of the polynomial function. Those are the zeros. I'm sorry, the x-intercepts are the zeros. Determine whether the graph of f crosses or touches at each of those x-intercepts. So we're going to set each of our factors equal to 0. So we're going to set the very first one equal to 0. That gives me an x equal to 0. So that would be 0, 0. Its multiplicity is 1. And that tells me the graph is going to cross. So I did it all in one fell swoop, basically. Okay, from the other one, we're going to get an x equal to a negative 2. That would be a negative 2, 0. That has a multiplicity of 2. That outside exponent is 2, which is telling me the graph is going to touch or bounce. So touch. I like the word bounce. Your book uses the word touch, but I like bounce. So again, the zeros are 0 and negative 2. As intercepts, they're 0, 0 and negative 2, 0. Those are the x-intercepts. What about the y-intercept? Well, the same way we've always found the y-intercept, you replace x with 0. So we're going to replace x with 0. And if you do that, you're going to get 0 times anything. We're going to get 0. So we get 0 times 0 plus 2 squared. You don't need to write this at all, which gives me 0, which I already knew. Why did I already know that? Because I already know that the x-intercept is at the origin. So if you're going to cross the x-axis at the origin, you also cross the y-axis at the origin. Now, it doesn't have a multiplicity. Okay, the y-intercept does not have a multiplicity. That is only the x-intercepts. We can't bounce at a y-intercept. So then goes on to talk about the end behavior. So end behavior. So we need the power function. So again, PF for power function. So if we multiply all this out, this would give me an x squared times an x, which is an x cubed. Now, in this case, the leading coefficient is a positive 1 written there. So we have an odd degree. That's the 3. And we know that the coefficient is positive, meaning greater than 0. So it's got a positive leading coefficient. So we know that this is going to start below and end above. And again, you don't need to memorize them because you should already know these from those initial library of functions that we did clear back in chapter 3. So it's nice. You shouldn't have to be flipping through the handout to find it. And finally, part C says the maximum number of turning points. So turning points, we're going to take our degree, which was 3. We're going to subtract 1 and end it with a 2. So at most, this thing will change direction 2 times. And that's how we analyze the graph of the function. Notice that these guys are all in factored form. If they're not in factored form, your first step is going to be to factor them.